Hello everyone, welcome back. In this video, we're going to apply some stoichiometry to solutions. In the write-up here, we read about how silver ions and chloride ions react together to make a precipitate called silver chloride. In other words, I can say, chloride ions precipitate silver ions out of solution. They form a solid precipitate. This is insoluble in water. This is one of the common things that we do with solutions in chemistry is use them to precipitate out metal ions like silver or some other metal ion. You may remember some of the stuff from doing some work on qualitative analysis. You can do precipitate tests to qualitatively determine for the presence of metal ions in solution. Anyway, so like one of the things that always works well with finding if there's silver in solution is to use chloride. Chloride precipitates out silver from the solution, and that's what's going on in this particular scenario. But we're trying to figure out quantities also. So this question says, what is the minimum volume? What's the minimum volume of this solution of magnesium chloride that we would need to precipitate all the silver ions in a solution with these figures of silver nitrate? So, like every stoichiometry problem, the first thing I'm going to do is write a balanced chemical equation. And this equation right up here at the top is just telling us some information. It's just telling us that chloride ions and silver ions precipitate. They form a precipitate. This is not something we're not building our equation off of this, or it'll be included in it, but this is a separate equation. Okay, so let's start out. We're going to take some magnesium chloride. And it's a solution, so I write aqueous. And we're going to react it with silver nitrate, also aqueous. So you can imagine we've got, one test tube with magnesium chloride, one test tube with silver nitrate. We mix them together and we get a precipitate. And in this case, what's our precipitate going to be? If you're not sure, maybe pause the reaction, think about it a little bit more, consult your notes. This is a double displacement reaction, so that means the metals are going to switch places. So we're going to form the precipitate, which is silver chloride, and we're going to make magnesium nitrate, which will be soluble. All nitrates are soluble. So there we have it. We have an equation. We do need to balance it still, and balancing it should be simple. We have 2 chlorines on the left. That means we need to have 2 on the right. Once we put a 2 here, that means we need to make sure we have 2 silvers to balance the silvers. And 2 silvers, we also have 2 nitrates, but we already have 2 nitrates on the right, so just do one final check. Pause the video here just to make sure it makes sense. Everything's good? Yep, I think it's good. So now we can actually start doing some calculations. So once again, we're asked for a minimum volume. We need to figure out what volume of magnesium chloride is required, and that unit will be in liters. We know that we have the concentration of magnesium chloride is 0.250 moles per liter. And we have some information here about silver nitrate. We know that it has a volume of 60 mils, and when we convert that to liters, we get 0.060 liters. It's got a concentration of 0.30 moles per liter. And there we go. So what's the common thing that we're doing in every stoichiometry problem? We're always going to be converting our initial measurements into moles. So I need to figure out moles of magnesium chloride, and I need to figure out moles of silver nitrate. And how do we do this? Well, you might recall that we can calculate moles using a concentration of a solution and its volume. You multiply them together. So concentration times volume gives you the moles. So what are my moles of magnesium chloride? It's going to be, well, that's my question mark. I'm going to have to figure that out at some point here, but I can do that by figuring out my moles of silver nitrate first. So silver nitrate, I can find its volume, I know its volume, its concentration. I can multiply those two quantities together to figure out moles of silver nitrate. So 0.060 times 0.30, and I get 0.018 moles of silver nitrate. So if I have 0.018 moles of silver nitrate, how many moles of magnesium chloride do I need to react with it? Well, my balanced chemical equation says that for every 1 mole of magnesium chloride, I need 2 moles of silver nitrate for a complete reaction. To get out all of the silver ions that come out of silver nitrate, I need to have at least half of that amount in magnesium chloride. So let's look at the mole ratio. So if I want to convert between these two guys, the mole ratio is a 1:2 ratio. So it's 1 magnesium chloride to 2 silver nitrates. So it's a 1:2 ratio, so it's going to be however many moles of magnesium chloride are going to be half of this amount here. So I'm actually going to do my work right over here. We'll say number of moles of magnesium chloride is actually 0.018 moles of silver nitrate. Times my mole ratio. My mole ratio is 1 magnesium chloride for every 2 silver nitrate. And you can probably do this math in your head. This is half of this amount, so that would be 0.009 moles of magnesium chloride. Okay, so that's useful now, because now I know how many moles of magnesium chloride are required to run this reaction. I know my concentration, the concentration of the solution that they'd be available to me. So now I can actually figure out its volume. And by rearranging this equation here, by rearranging the concentration volume moles equation to solve for volume, I can do volume equals number of moles over the concentration. This will tell me how much I need. So I have 0.009 moles of magnesium chloride, and I divide it by my concentration, which is 0.250 moles per liter. And this gives us a volume of 0.009 divided by 0.250. We get a volume of 0.036 liters, or you could write it, that's 36 milliliters. And it looks like I'm only allowed to have 2 significant digits, so I'll just keep it like that. That's fine. Volume is 0.036 liters, or rather 36 milliliters. Okay? If there's something at all or anything in this video that doesn't quite make sense, maybe leave a comment or a question, and I'll try to address it. If it requires like making another video, doing another example, I can do that too. All right, see you in the next video.